Okay, here's an 8-bit CPU that I'm starting to build on breadboards. This is the clock circuit up here, the first chip. It's a clock. It produces a timing pulse. It's a square wave. This is the timing pulse, the square wave that's created from the clock. Right now the clock is set to run continuously with this switch. If I move the switch, however, I can put it in manual mode. Now you can see the green LED doesn't blink anymore, and we don't have any more pulses because it's in manual mode. So I have a switch that I can push to create a clock pulse. This will come in handy when I'm debugging the computer to try and find out what's wrong. I can go one step at a time to find out what's wrong. So then the output from the clock goes through this blue wire over to a 4-bit counter here. So this is a 4-bit binary counter. I'm going to reset it. I'll explain that in a minute. So right now we're at 0. We have no LEDs lit and our display shows 0. So if I use the manual clock pulse to go 1, we light up the first LED, which is the low order bit, which is either a 0 or a 1. A 0 is off and a 1 is on. Now I'm going to click the pulse once more. Now we're at 2. So the first LED which went off is either 0 or 1. Because it's off, it means it's 0. The second LED is a 2. It's either a 2 or a 0. And it's on. So now we know our total is 2. And that's what our display shows. We click one more for an additional pulse. Now we have a 1, which is the first, and a 2, which is the second. Added together makes 3. Now we click again. Now we have a 4-bit. So the 4 is on, that means we're at 4. We click 5, 4 and 1 is 5, 4 and 2 is 6. 4 and 2 and 1 makes 7. Now all 3 turn off. Now the 8-bit is on. And 9, and 8 and 2 is 10. 8 and 2 and 1 is 11. 8 and 4 is 12, 13, 14, 15, and now we're back to 0. So the clock creates the pulses. This is a 4-bit counter here because it's 4 bits. We have 4 LEDs, which is a 1, a 2, a 4, and an 8. So the highest number you can get is a 15 using the 1, the 2, the 4, and the 8. I'll probably expand this to an 8-bit counter, which will take it to 255, but I haven't done that yet. And then this is the decoder here. It's binary coded decimal to a decimal display. So, and with this decimal letter here, we can't actually display numbers greater than 9, so it shows funny characters. They are always the same, but you don't know what those characters are generally. So, and then back to the reset over here, I have a separate set of chips here, which if I press reset, if we're in the middle of it, say we're at a 6, and I press reset, this reset sets everything back to 0. And then I can put it in automatic mode here, and now it'll start to count one by one. I can also change the speed of the clock. I can make it go faster. So now we can see it's counting much faster than it was before. Or I can slow it down very slow.